Hello friends, welcome back, and from this video we are starting compile a design, and today we will try to understand top down predictive parsing, and we will take an example of a GATE CSE 2003 question number 56 to understand LL1 parsing technique. So let's begin. So a little bit introduction to predictive parsing. It is a top-down approach. That means we will have some production rules, context-free grammars production rules, and we will start from the starting variable of the rules to predict whether the given sequence of tokens we got from the lexical analysis can be derived from the grammar rules or not. Okay, so it decides which production rule to use, avoiding backtracking. And the name LL1 means L means left to right scan. We are scanning the input tokens from left to right, and this L is for leftmost derivative. That means the parse table we are forming using leftmost derivative. And we use this one is for how much extra information or hint about uh, see, suppose this is the grammar A, B. We will take an example. A, B, B. This is producing A, B, B. Okay. Now, if how we are feeling, what is this one? We are taking that from S, the first terminal symbol of the sequence, non-terminal symbol we are getting is a A. So from this S producing A, this rule, the first terminal we are getting, leaf node we are getting is A. So we will use this information to decide that if in the input token stream I get an A, then I can reduce or use this production rules S derives A. So yes, so LL1 means L left to right scanning of the tokens, and this and second L is for leftmost derivation, and the next one is using how many input tokens, or you can say evidence. What is the next terminal that you are expecting in the sequence, and the non-terminal, what is the first terminal character it is producing. Using this hint, you are guessing which rule to expand with. A, S derives capital A or S derives capital B. Okay. See, capital B produces B. So definitely we will be using S derives capital A over here. Alright. So we are using the first and follow sets. So this process is efficient and predict deterministic, right? Okay. So let's move ahead with the next slide. Okay. Now this is the question 56 from GATE 2003. Okay. This is the grammar given. Now in this actual question, we were supposed to find only two entries. We have to tell M of S dash comma E and M of S dash, sorry, these two entries of the parse table we were asked in the question, and M of S dash comma dollar, these two questions, but we will make the whole table, okay, for practice. So let us copy this question to our open board. Let us copy this and So this is our grammar. So what we will do, we have to make the parts table. So we will calculate first of all the non-terminals. First of S, first of S dash, first of E, S dash, first of E. Okay, so first of S is I and A, right? Small I, comma, A, right? What is first of S dash? It is producing E and epsilon. E and epsilon. Okay. And what is first of E? That is only B terminal it is producing. Now, when in S dash you are getting epsilon, that means when you are expanding S into I, E, T, S, S dash, and then it is leftmost derivative, so obviously E will be expanded then to B, and then this S would be expanded. Suppose this S is small a. Now, if your S dash, it is replaced with epsilon, okay. So we have to see this is replaced with nothing. And I know every string is terminated by a dollar symbol. So we have to see, we need one evidence of what is the next token to make the parse table. So we will use this evidence that after S dash, we will get a dollar symbol. That is, we have to calculate the follow set of S dash. So that is equal to dollar, as well as, see, where else? Now S dash, okay, from here we will see. So follow of S dash we want. Follow of S dash is same as follow of S. And here follow of S is first of S dash. Okay. So first of S dash will be equal to E. We will add. Okay. So these two we are getting. Means I hope you have understood this part, as first of S dash can be epsilon or nothing as well. But for putting the entries in the symbol table for this production rule S dash derives epsilon, we need which terminal follows this, which terminal is coming next in the input token sequence. As it is replaced with nothing, so the follow of this terminal, this part, will be used as a evidence to be using this production rule. Okay. Now what we will do is, next slide we will add one more. We will make the parse table. So on the rows we will write all the non-terminal symbols. S, S dash, okay. S, S dash, capital E. I think these were only the, okay. Yes, S, S dash, capital E, okay. And the terminal symbols are I, A, T, okay, I, A, T, B, E and dollar. I, A, T, B, E and dollar symbol. Okay, link I, T, A, E, B and dollar symbol. Yes. Now which rule? Suppose your sequence of tokens on the stack top, you have S non-terminal and the input is I. So can any rule produce I? Yes, first this, from this production rule, I will erase the ink from here. Okay. So this rule IETSS dash, from this we can derive the first terminal I. So I will write this production rule over here. So we can number the rules. Okay, we will number it 1, 2, 3, 4 and 5. So we will use production rule. This S derives ET, this one as 1. Okay, so I'm writing these as production P1, P1, okay, using production 1. P1, okay. Now, yes, A is producing using production number 2, S derives A. So, production number 2. Can we get T from S? No, it is not in the first set. Okay, we can get E from S dash using rule 3. Using rule 3, P3, okay. And epsilon is S dash producing epsilon, we have to use the follow set. So after, cause it is epsilon empty string, after that we will get dollar and E. So under dollar and E and non-terminal S dash, we have to put rule number 4. Acha, okay. From S dash, wait. From S dash, the first terminal is E. So we have to remove this. Okay, P3 is not here. P3 is from S dash. P3, right? P3. Be careful about this. And from E and dollar using P4 we are substituting. Yes, S dollar and E using P4 on S dash. So P4, so here you see two possibilities. So the first terminal E can be produced from S dash using two possible production rules. Okay, so that is a confusion. Two different meanings, two different parse trees can be created. So from here only you can say that this grammar is not an LL1 grammar. It is not a predictive grammar. There is an ambiguity over here. Okay, so next, first of E is B. So using rule number 5, production rule number 5 under EB, we can find using rule number 5. Okay, so this is our parse table. And the question was asking us, the gate question, we will see. Yeah. It was asking us about what is the entry of the parse table S dash E and S dash dollar, right? So here are the entries. S dash E, we have two entries, P3 and P4. That was S dash derives ES and S dash derives epsilon, these two, comma. The next on dollar symbol, it is P4, that is S dash derives epsilon. So this is the answer. Okay. So yes, we have done this part. We have calculated the parse table using first and the follow sets. Okay, it is written in technical language. Okay, so next we will see. Yes. Okay. Yeah, so to summarize the key takeaways, predictive parsing, it avoids backtracking as we are using a parsing table, fixed data structures. It requires unambiguous LL1 grammars, but in our question it was an ambiguous grammars cause in the parse table two production entries were in the same non-terminal versus the terminal column. So ambiguities must be resolved. Okay. So thank you for watching with this video. Please don't forget to subscribe to my channel and please stay tuned for more compiler design videos. Bye bye. Take care.